Like you can just like imagine it, you know? Right. So like
All right, guys, let's go ahead and get started over here. My name is Andy Wu, and I have a confession to make. I am completely incapable of flying those toy UAVs. I cannot do it to save my life. But luckily, I'll tell you guys later that doesn't matter. So let me tell you a little bit about myself and my background. So I'm actually a Ph.D. candidate here in business economics and public policy. And I do a number of things to support entrepreneurship around campus and beyond campus. So I advise a number of entrepreneurial firms, in particular a UAV company that I'm going to talk about in a little bit, and some others. I've done work in public policy to improve the regulatory environment for entrepreneurship. And I also spend most of my time doing research and teaching on entrepreneurship. In particular, I study decisions that venture capitalists make and how management teams can organize for additional innovation within their firms. So this is the company that I work for now. So I'm a founder and director of the company. I'm not engaged full-time, but you know, I fly out there every month and we still work on a lot of stuff. So the company delivers unmanned aerial systems for surveilling and monitoring and sensing in the upstream energy industry, particularly oil and gas and mining. So let me show you guys a video of what we do. So we deploy these systems on client sites. They automatically fly out around the client site, collect whatever data they need. So that can be visual data, gas data, infrared data. automatically come back and land. Now inside that box, the dock station we call it, there's a system that swaps out the batteries on the UAV, and I'll come back and talk about that, why that's an engineering challenge later in the talk. Go out on the next mission. So what you didn't see in the video is that inside the dock station there's going to be a radio sensor that kicks out data to the cloud. It's going to automatically transfer the data to our cloud-hosted site, and then the client can view their data through our site. Okay, good. All right, does anybody have any questions? So the one thing I want you guys to take away about our business in particular is we actually don't sell our system. So our system is the three-part thing that we would call the UAV, the dock station, and the cloud hosting segment. So we actually don't sell that to the customer. We lease that out to the customer on a month-to-month basis. So we're actually going for a SaaS-type business model. And I'll come back and talk more about that later. Good. All right, so in today's talk, I'm going to talk a little bit about why UAVs are popping up right now, why that's a thing right now. I'm going to try to argue to you guys that it's not a fad, although there's certain components of the current rise that are fad-like. We're going to talk about the state of existing UAV technology, where I see current industry applications, what are the kind of challenges that we face in the industry, and then where's that market going, and if you guys really like what you see here today, how you guys can get involved yourselves. Good, so why now? So let me make an analogy first to another industry out there that I think is an industry that has been slightly disappointing. 3D printing. So I was there starting in the late 90s, and I think it's one of those technologies that anyone can see it and anyone gets it instantly. It's beautiful, everyone loves it. The problem is, though, it's always been the next big thing for several decades now, and it's never actually popped up. And it's curious as to why. So I'm going to argue with you guys today that UAVs are not of that sort. So UAVs are something that is a real thing that's going to disrupt how we think about aircraft. So why is UAVs popping up now? Is it a fad? I'm going to argue that it's actually the intersection of several different independent trends that are coming together all at once. So the first trend that you may have guessed already is military investment. So the military has always seen the use of UAVs for a variety of reasons, which we'll come back to later. But first and foremost, you can imagine safety is one of those. In a lot of cases, it's better not to have real pilots out in the field. So the military has been pumping in hundreds of millions of dollars into this technology, probably in the billions. Even Penn itself has gotten, I think, millions of dollars in grant, probably close to $100 million in grants to study UAV. Most of our peer universities have always also gotten that kind of money. So a lot of this is being driven from the military side. Falling costs of small electrical devices, and this is sort of an interesting trend, and this is something that's independent of UAVs. So because of intense competition in the smartphone industry, the price of GPS, the price of accelerometers, and the price of all the other processors and components that go into your phone has been falling dramatically. Now, we didn't drive those costs down for UAVs, but UAV technology can leverage those falling costs. So we're going to integrate a lot of those sensors into our platform, and that allows us to find even more applications for our technology. Falling manufacturing costs. This is true across the board, but in particular for a lot of the smaller commercial products, you can imagine historically in the aircraft industry, you have very, very large players. You have your Boeing, your BAEs, your Lockheed Martins, and these are massive companies with massive budgets who are actually moderately inefficient about what they do. And it's pretty hard for small business players to compete in those markets because you don't have the scale. Now we have manufacturing costs, in particular rapid prototyping, 3D printing and stuff, have driven those costs down. The open source movement, and this is sort of an interesting, I don't know if it's intentional, but an interesting nuance in the industry. So 3D robotics and a lot of the early players and key players have made a point of making a lot of their platforms open source. So we actually use a lot of 3D robotics technology in what we do. And they provide processors and software and everything that we can work with and modify. And so that's worked out in the industry. Also, in addition, a lot of the technology that goes into UAVs has already been patented a long time ago, so past the point of expiration. So a lot of those patents have expired. So there's been a lot of room for people to work on the product without being encumbered by that. The maker movement. This is sort of a smaller thing, but this more relates to what you'll see around here in the city in terms of amateurs using UAV aircraft. So there's been a recent trend in these maker shops and hobbyists to build their own products of any sort. In this case, a lot of people do build UAVs for fun, so that's gotten to be a pretty common thing. Internet of Things. So this is a broad trend. I don't know if this is going to end up popping up, but this is something that a lot of people believe in. Probably half this room is probably fans of this trend. But basically, you can think of products like Nest that are integrating sort of the controllers that we have around in our lives into the internet. There's a goal eventually that we have in the industry of bringing the UAV and connecting that to existing platforms and internet and everything else that we have right now. Finally, this is the one that personally annoys me a little bit, but it's probably going to happen. So big data is one of those things that I think can have a lot of value, but I don't think we've discovered all that value yet. So if you think about the data that we're collecting in the internet right now, we're collecting mounds and mounds of unstructured data, so text. But we have no way of analyzing that text. Right? There's just too much data. Like the FBI literally had Tsarnaev in their database and then didn't spell it right and couldn't match it up. Right? That's the kind of challenge that we're facing with big data. And we're going to face that with UAV technology, because what UAV technology is going to allow us to do is collect more and more data than we ever thought possible. Right? Aerial data, infrared data, anything, and put it into the cloud. So in order for UAVs to really achieve their full potential in creating value, we've got to figure out better techniques for analyzing that unstructured data. So we'll talk a little bit about that. Good. So let's go over quickly the state of UAVs. This is an extremely quick overview. Also, as a confession of mine, I'm also not an engineer. Actually, I was an undergrad math major. So I'm not the best person to ask specifically about the nuances of the technology, but we'll go over quickly about what you guys might want to think as business managers about what's going to be relevant for you guys. So there's a couple different categories of UAVs. So I'm going to group them by size because I think that's the easiest way to understand sort of what their strengths and weaknesses are. This is the Northrop Grumman Global Hawk. So the wingspan on this guy is about 5 or 6 car lanes wide. It's an extremely large aircraft. So the analogy that you might make for this aircraft is it's close to the U-2 spy plane that we used historically in the past during the Cold War. And the advantage of this thing is this thing can fly for forever. It can fly continuously for 24 hours or more. I think in tests they've done, it flies for 33 hours. This thing flies extremely high up, and we can put it in enemy territory pretty safely and then collect data perpetually. So I'm going to link back to it later when we talk a little bit more about the defense industry. But in particular for this plane represents a sea change for Northrop Grumman as a company. So Northrop Grumman used to provide a lot of military services. In particular, I think their most famous thing was they built most of the largest aircraft carriers that the U.S. has today. Now, in that, what they've discovered, what Northrop is pushing for, is that they think that the need for aircraft carriers and that type of stuff in future American warfare is going to be less and less and less. So they've, as a company, have invested an extremely large amount of money and effort into delivering these kind of products. All right, so slightly smaller than the largest ones this is the General Atomics Reaper drone. So this is the newer generation of the Predator drone, which is slightly smaller than that one. So the difference between the Reaper and the Predator is that the Predator was intended originally to be a surveillance aircraft, right? So these missiles that you see added onto the bottom are not really supposed to be part of the airframe, but they've ended up making it work. So this one in particular is probably intended in its design to be a hunter-killer UAV. Now, one thing I'm going to actually, let's punt the discussion until later. I'll link back to the military discussion later. Good. All right. Then we have smaller UAVs. So this is still a fixed wing design. So wings, and this is a particular structure that catapults the UAV and then allows for Marines on the ground to get real-time surveillance. All right. Now we're getting smaller. So this is a DJI Phantom, and you'll notice that we've shifted over from the large to the small. We've gone from fixed-wing aircraft to rotorcraft. So there's a number of advantages to rotorcraft at the small end of the scale. One of those advantages is precision control. Like you can get a lot more accuracy. And interestingly, you can also stop. So you can't stop a fixed-wing aircraft in midair, right? But you can stop a UAV and pause it in midair, right? Allowing for precision photographs of specific locations. Good. And then we have our smallest ones. So this is actually a product by K-Mel Robotics. So K-Mel Robotics was a spin out of the University of Pennsylvania. And these robots currently are only for, I think really only for research testing. What we might want to look for in the future is there's a number of, like, for the big dreamers out there, there's a number of ways we can implement these smaller aircraft in ways that frighten me a lot. But basically, you can imagine a swarm of these aircraft doing collaborative activities together. So one thing they've tested is you can use multiple of these to do a sling load and carry objects, right? So, but that's currently in research, and we're probably a bit further away from really using these smallest ones. Most of our discussion today will focus on these smaller ones because that's what we do. Good. Does anybody have any questions so far? All right, so a couple distinctions I want to draw right now. So first thing is you saw the distinction between fixed-wing aircraft and rotorcraft. There's a number of intermediate designs between those two, but you can think of those in broad categories. You're also going to want to think about the distinction between pilot on the ground versus autonomous. So whether or not these UAVs are being piloted by a human on the ground or whether or not they're automatically flying. I'm going to argue with you that distinction is relatively pointless. It's actually not really relevant. In a lot of cases, the autonomous is better than the piloted on the ground. We'll come back to that. Good. So to give you guys a sense of the size of the UAVs we're talking about, so the Global Hawk is this guy here. And then what we do is right around here. So the industry is very diverse, very large. All right, so let's reflect on where we can and cannot use UAV technology. So when do we want to use UAVs? So this first one is pretty obvious. It's wherever aircraft is going to be useful. Now, what's interesting about that statement is that aircraft can be more useful in more places than they have been before because we're taking humans out of the situation. So there's a number of reasons why we might want to take humans out of the aircraft, right? The first one, obviously, is safety. If you're flying a spy plane over enemy territory, you don't want humans in the aircraft. That's sort of obvious. In terms of carry capacity, by taking humans out of the aircraft, you reduce the need for a lot of life support systems and controls and everything. You take that all out. Weight. So that we're able to achieve, obviously, if you don't have humans, you can build very, very tiny aircraft, right? And then control. I'm going to argue with you through our talk today that commanders on the ground and pilots on the ground are better than pilots in the air. Right, so there's a number of reasons why that might be the case. One of those is, what we'll loop back later, is collaborative behavior. So if you want to control multiple systems and coordinate multiple systems, it's easier for one person to do that on the ground than two pilots in the air. All right, so I'm going to make a very bold prediction of the day. I feel like I'd be ripping you guys off if I didn't. I'm going to argue that UAVs are going to replace all aircraft. I forgot to put a year on that, so let's say in the next 50 years. I think they're going to replace all aircraft except in human transportation. So obviously if you're moving people from one continent to another, you can't really replace that. But I think I'm going to argue that logistics aircraft, military aircraft, commercial monitoring aircraft are all going to be replaced by autonomous aircraft. So all right, so we're going to go through a bunch of applications that you might see for UAV technology. So the first one here is national security. This one you've seen already. People actually protest on campus about this. I think there's very valid debates about the use of UAVs in national security. I will argue, though, assuming conditional on you believing in the mission of the Pentagon, like UAVs are the way to go. So there's a number of advantages to using UAV aircraft. So the first advantage here I'll point out, or actually the main advantage I'll point out, is that we're able to have multiple systems in the air at the same time. So if in the peak of the war in Afghanistan, we had hundreds of aircraft going over Pakistan and Afghanistan at any given time, circling around the country. Right? So the advantage of this is that it gives us constant monitoring of the country. So we can see the entire landscape at any given time. Now, this is very useful to us in today's current warfare. So back in the day, if you're in the 1970s, the image for a war was that you had to go into the massive land invasion, land a couple Marine expeditionary units, and go on full-out invasion. That's not how wars are fought today. They're fought on the ground in very precision environments among civilians. Right? So precision targeting is extremely, extremely important. So by surveilling the whole country at any given time, they can literally wait for the enemy combatants to come out of their holes and then strike them exactly the moment they decide to show their face on the ground. Right, so that's what it gives us. So you might be wondering why, okay, then maybe you could just use satellites. There's many obvious drawbacks to satellites. The first obvious one is it doesn't work if it's cloudy. Right, and then also you need it to pass over at the right time. And they're also prohibitively expensive in many cases to run. Good. All right, law enforcement. This one is one that we've encountered ourselves. So we had a number of people reach out to us about, how to use UAVs for law enforcement. So we've worked with the Allegheny County, so that's the Pittsburgh Police Department, to try to implement this. So this is the one I think that people have a lot of concerns about, and I'm not going to try to dispel any of those concerns. Essentially, let me give you a case example of what you might want to use these sort of UAVs, and you can imagine the sort of picture the smaller ones here. What they're picturing, so I've got a picture here of Florence and Normandy. Does anybody know what that is? So Florence and Normandy was where the LA riots started, right? So that's a situation where law enforcement was actually, they were pretty much too scared to go there because it had gotten out of control and they weren't ready to react. So what many law enforcement officials are picturing is in those environments, they can send UAVs out to monitor the area, record the area, and then locate if anyone's committing any crimes or anything, right? Extrapolate that even further. We can think here in Philly. So if you go down to 40th and Market Street, there's a subway stop over there. After it gets dark, so I've spoken with some law enforcement officers about this, and I visited their command center. There's about a drug deal happening on that corner every 30 minutes when it gets dark. So if we're able to put a UAV in the air, permanently monitoring that spot, you can record all those transactions happening and potentially put a lot of people behind bars for that. Now, I think there's a very valid debate about whether or not, obviously you can debate about the drug war, but as it stands, that's the law in the books, and that's the law that law enforcement wants to enforce. If you want to give them the power to enforce that law, then this is a very, very strong way to go. Now, the question, if you don't want them to enforce that law, perhaps we should wipe it off the books. I think that's a valid debate. But if you want them to do it, this is one way to do it. All right, oil and gas. So this is what we do in particular. So there's a number of spaces in oil and gas for UAVs to work. So the couple things that we've done is we fly over pipelines and monitor pipelines for them. They're required to do inspections every so often. And generally, they want to do it more often as often as possible. So to give you an example, sort of the scale, one of our clients, they had a pipeline running, and one of the pipelines got knocked out by a mudslide and they didn't realize. And then they were losing about $1 million an hour because they couldn't catch it. So our technology is cheap enough that you could potentially monitor it every single hour, every single day with relatively little problem. Beyond that, the other thing you might imagine is oil and gas exploration. There's a number of ways to implement that. That requires a bit more sophisticated sensor technology, so we haven't gotten to that yet, but that's another thing you can do. There's a number of compression stations out there, and you're going to go around and scan for that. That's been useful. Now, let me link back to my prior point earlier. So I made a point earlier about, we wonder why 3D printing hasn't exploded in the way that we want it to explode, and why I'm going to argue why UAVs are going to, end up being successful. So this is an industry, the oil and gas industry, already uses aircraft. So what they do is they have two forms of monitoring their equipment and looking for oil and gas. The first is they put boots on the ground. So they have men will literally walk down the pipelines and walk across the fields and then look for suspicious things with handheld sensors. That's prohibitively slow and prohibitively expensive, but that's actually the dominant form used today. So you can imagine being in Texas and it's 100 degrees and you have to go out and do that. That's pretty bad. On the other hand, so we also have aircraft in the air. So the aircraft in the air costs actually a lot of money to put out, and it's hard to book in advance. It actually takes some weeks in advance to book a flight for a regular aircraft to pass through. Fixed wing or rotorcraft. So that's a manned aircraft. And finally, they also use satellites to do their work. Satellites are obviously provide a lot of scale. You can capture large areas. But again, you have to book it pretty far in advance, and it doesn't really give them the sort of quick data that they're going to want in terms of monitoring and exploration. So the UAVs have a number of technologies over the existing things. Now, the difference between that and 3D printing is that in 3D printing, the use case didn't preemptively exist. So we have a new technology, and we're trying to push it to new users who don't already use that sort of stuff. Here, the oil and gas people, and all the other industries we're going to talk about, already do what we want to sell them to do. We're just going to do it quicker for them and cheaper for them, right? But the exact same thing. All right, mining. So this one's an interesting case. Let's start with sort of the future of where this is going to go, and then what we currently do. So the future of the technology, and this is less about UAVs and more about computer vision. So you can imagine you're drilling down, and then you have a narrow pipe through the ground. You can fly that UAV in with a camera, and it's going to bring in that data, and then build a 3D model of the tunnel, right? And you can fly in, and the UAV will use the data it has from the camera, and then continue flying through the tunnel automatically, and you can map out your entire tunnel in a 3D fashion. So that's actually more about computer vision and less about these aircraft. Let's talk about what we do here today. So out in Appalachia, they have this thing called mountaintop mining. Some people call it mountaintop removal. But the general idea is that under the mountains, there's tons of coal. And what they're going to do is they're going to blow up the top of the mountain and then get to the coal underneath. Now, the interesting thing about these contractors is the way they're judged. So there's a company that owns the mountain, and then there's a company that does the removal of dirt. So in terms of removing the dirt, the people who do that are judged and billed on how much dirt they can move, which makes sense. So they build these massive mounds of material that they removed, and then they need to measure the volume of that material. So we'll fly around, capture the images, build a 3D model, and then do volumetric analysis of what the size of that mound. Right? And they need this done every single day to measure their progress. All right, construction. So this is actually a picture. So this is by the way, this is a real picture that we took, and this is also a real picture we took. This is, I think, the 5th photograph we ever took on a real client site. So this is a new building that Mascaro Construction is working on. And for construction companies, there's a number of reasons why they might want to monitor their sites. So the first reason is that if you follow how construction works, there's a main contractor, and then there's countless numbers of subcontractors, right? So the main job of the contractor is to make sure the subcontractors are doing their job. By constantly putting aircraft in the air and monitoring it as frequently as they want to monitor it, they can make sure their subcontractors are actually doing their job. The second thing, and this is sort of more nuanced, is that it's sort of a marketing thing. So there's an interesting thing if you guys are future CEOs of companies and you order the construction of a new building, it actually makes the CEOs very happy if you can show them a time-lapse picture every single day. For some reason, they really, really like that. So, because their life achievement is growing, and we provide a lot of those images. I think that's sort of a lower value add component of the business, but for some reason they really want it, so let's do it. Delivery. So this is one it's tough, but it's one that's been part of the dreams for a lot of people in the industry. So you might have seen that Amazon video on 60 Minutes presenting this technology. I'm going to tell you right now that they way oversold what they're capable of, and I'll loop back to that when we talk about the engineering challenges. But this is something I definitely see as possible, and I believe Amazon's metrics for why they want to go for it. The main reason is because the average Amazon package, and package in general, is not very heavy. It's actually a book or something pretty small, a small electronic component, right? That can be delivered via these small aircraft. Now, the tough thing that we're facing here today, and so DHL's own analysts have talked about this. DHL is actually going for the exact same thing. The regulatory environment for this is going to be extremely challenging. I'll loop back to that at the end when I talk about challenges. The problem is that it's going to require that Amazon fly basically through big cities and in populated areas to deliver these packages. So we'll talk about ways you might get around that. But the one place that DHL's analysts have stated that this technology is going to be really useful is in rural delivery. So rural delivery, if it's just a small package, you may not want to send a full truck out there, right? So then it makes sense to send a small package via this way, and you're not running into those sort of barriers where you're flying through areas with a lot of humans. Agriculture. So this one's pretty straightforward. You fly over the crops, you see which crops are growing, which crops are not growing, and then water it. And I don't really understand plants, so you can sort of guess what they're going to be doing. But yes, I'll leave that to you. Leave that to the reader. Forestry. So there's a number of ways this is implemented, but you want to check out which parts of the forest are being cut down, how to monitor the progress of your contractors, or you might want to use it from an environmental perspective to monitor where there's illegal activity happening. So that's also pretty straightforward. Oceanography. So what I should have really labeled this is oil and gas part 2. So the way our team sees it is that the biggest money in oceanography, using these aircraft for oceanography, will be to service actually very upstream oil and gas companies. So in that case, you might fly through. You can monitor their oil rigs. You can do a lot of stuff analyzing the water currents and all that sort of stuff. So we think that oil and gas companies are going to need that service first. But obviously for organizations like NOAA and stuff, they're actually already implementing sort of larger UAVs out there and running that through and using that to collect data. Sports and media. This is one you've probably seen already. A lot of movies and movie makers have already started using these aerial vehicles for filming things and trying new kinds of camera angles that you weren't able to try before. I don't in particular think this is a super lucrative market. I think there's better ways to go if you're going to bring out that technology. That said, I think it's going to make money. The one issue is that some of the better cameras out there are a bit heavier than we'd like to carry on these aircraft, especially these small aircraft that you see here. So we might have to bring down some of that camera size technology. But again, I think this will be profitable. And finally, you can use it as a toy. I picked this picture because that guy looks way too happy. But I will give you the point here that actually I have some personal concerns about using it as a toy. It's actually, like for the better UAVs, it's like semi-dangerous to fly them. First of all, they're actually very, very difficult to fly. And second, actually, if you get hit by one, it could potentially be very damaging. So like the rotors are pretty sharp, and actually it's like a little bit unsafe. So when you guys have kids in the future, I'm not entirely sure you should advise them to do it. You have a question?
Yeah. So right now you have companies that are releasing these and surveying their own grounds. How do you prevent them from like doing industrial espionage and various illegal activities with the drone?
But you're coming from the perspective that we should stop it. The tough thing here, and I'll talk about this in the regulatory environment discussion, it's extremely difficult to regulate and stop these things. The government doesn't have the capabilities to really limit that sort of activity. I think that's got to be done on a case-by-case, like a lawsuit-driven basis. So if you're spying over somebody else, I think then you can bring a lawsuit. I don't think it's going to be regulated broadly. Does that answer your question?
I guess that you can find ways to kind of insulate your product from being dragged into this type of process. So
like one issue, are you looking from the side of someone being spied on or someone who wants to be spying? So you want to prevent spying? Yeah, so I'm confused.
I have no moral anything to do. I'm just curious, like if one company decides to use your product to spy on another company, how does that affect your company? Like if they're using your product to do something illegal, will you get dragged into the whole legal?
For our business, we would, because we're the ones doing it. Like we run the system for the client. Okay. But if the client like owned their own, I guess it'd be theirs. I don't know. I'd assume it'd be theirs. So one thing we're going to come back to, and I'll get you in just 1 second. So one thing we're going to come back to is that a way to prevent that is there's going to be an ongoing cyber intelligence and cyber warfare battle over the signal communication between the UAVs and the ground. Right? That's something that's going to be a challenge in the future. Go ahead.
I was just going to say that to address that problem, the technology exists in what's called geofencing. So you can incorporate the software on the drone or the control software of the drone. The ability to just prevent it from entering certain geographical areas. And so you can do that on a case-by-case basis, but you can also do that if in the future there is sort of a platform, a universal platform that everyone who has a drone for commercial use is going to be using. Then those rules and that logic can be built into that platform so that you can prevent entry into certain areas.
Great. Yeah, no, I think it's a phenomenal comment. So in these aircraft, there's going to be a number of automated flight behaviors built in. That's one of them. The other is automated landing. So if systems start failing, if the battery starts going down, it's going to automatically land. So that's all stuff that people have thought about. It's hard to prevent if someone's maliciously doing it. If someone intentionally wants to do it, I'm not quite sure what you would do. But we'll come back to that in just a second. Good. So there's a number of engineering challenges that we're going to face in this industry. So actually, more than just engineering. So this is all stuff that's going to be relevant for the industry applications we've talked about. So the first is that degree of autonomy. So the first thing is that most of these things are going to be running off GPS. GPS has a certain limited bandwidth of accuracy, and you might want to get more accurate than that. So if you want to get down to the accuracy of centimeters, you're going to need alternative technology to make that happen. So one thing that we're going to see more in the future is sensor fusion going into these UAVs. And by sensor fusion, I mean using multiple sensor platforms, so visual, sonar, and GPS together to triangulate a location more accurately than we can today. So that's something that's going to come up in the future. And second is cooperative behavior. So this is sort of an interesting one. Actually, before I get on cooperative behavior, I do want to talk about the accuracy. So one of the dreams of the U.S. Navy is they want to replace all their aircraft carrier aircraft with unmanned aerial vehicles. And they've done a great deal to move along that route. So Northrop Grumman has great technology for that. Now, where we see that going is essentially that'll allow the military to remove many of the pilots off the aircraft. In many ways, these unmanned aircraft are actually better at landing than manned aircraft. So that's actually one of the biggest challenges for aircraft carriers in general. And because there's less people on board and the aircraft are generally smaller, you're going to fit more of these on board. All right, so let's talk a little bit about the cooperative behavior. So you may have seen this video, but it's great, so we're going to watch it anyways.
Developed a nano quadrotor capable of agile flight.
So the way these aircraft are being flown is they have special like visual dots on top of them.
Multiple
And then there's
vehicles can fly
ViCams, so
as a
very
formation.
expensive cameras around the room that are tracking the precise location of where these UAVs are. So the engineering that they've done here, I think, is approaching the nightmare that many people have had about this technology.
We developed a method to transition between formations in 3D. The team can also navigate in environments with obstacles.
All right, so just for the record, Vijay Kumar is now the dean of engineering here. So this is also here at Penn. So while you guys were at the white party, this is what the PhDs were doing. So that's either like very glorious to you or very much a nightmare. Go ahead, sir.
How long did that take to program?
This video
I
presents
don't
the
know, like,
finest
that's probably
control
like-
capabilities
sorry,
for
one
a
second.
quadruped helicopter. We use a 20-camera Vicon system and an onboard eye.
I think they wrote a research paper about it, so I'm going to guess like, I don't know, like half a year or more. So this was a bit earlier in the technology. This is a couple years old now. So this is when they're still developing a lot of that platform. So I think there's a lot of work that went into that as well. But it was like a non-trivial amount of time. The one nice thing about their system is they do have ViCam around the room. So there's going to be cameras that give them very, very precise location measurements that allow them to do that kind of project. So yeah, so this is Penn's research. Glorious stuff around here. For the MBAs in the room, I do encourage you as you guys, either close out your year here or go into your second year, try to engage the other resources here at Penn. So this is a group that actually for years have been begging for basically MBAs to come and make money off what they do. So and many other groups here at Penn are like that, in the med school, engineering, wherever, even the vet school, nursing school. So go ahead and reach out to your resources at Penn and really help people make money, right? Because that's what you really want to do. All right, so collision avoidance. This is a really, really big one. There's a lot of research and from both the commercial side and the research side into collision avoidance, so what we call detect and avoid. So if you're flying through a city, you don't want to hit stuff, right? This is a big issue for other kinds of technology as well, but it's actually a somewhat difficult engineering challenge. It requires a lot of technology in both the precision of the aircraft itself, like knowing its exact location in space, as well as computer vision, the ability to detect obstacles coming up in the air. But you can also use sonar for that. So this is something that I think is within reach. I think we're going to have a pretty good set of this technology in the next 10 years, but currently it is an engineering challenge. So this is one thing that Amazon will have to work on if they're going to want to bring it out to do package delivery. Endurance. So especially on the small end of the scale, so I told you about the large ends of the scale, they can fly for a very long time. At the small end of the scale, we have a unique engineering problem where we have a trade-off between using larger batteries on the aircraft, but then when you use larger batteries on the aircraft, you make the aircraft heavier and you lose a lot of flight time. So for our product, we spend most of our time in the UAV technology cutting off weight and increasing flight time. So we integrated a patented carbon fiber frame. We've eliminated most of the excess plastic to get as much flight time out of our aircraft as possible because we cover fairly large client sites. Now, a lot of the consumer products you're going to buy on the market, UAVs, are actually quite heavy. There's a lot of excess plastic on there that is purely for decorative purposes. Like at the small end of the scale, we actually don't have time for that. Like there's not enough battery life to like blow space on that. So battery technology is going to be a huge limiting thing. Just for your reference, this is actually an even bigger problem for you guys with the cell phones in your pocket, as you know already. I remember Nokia used to last like forever, right? And then now I can barely make it through one day with a cell phone battery. So I don't think the technology in this space is going to be driven by UAVs, not at all. But I think there's a lot of push from other markets for better battery technology. I think you can have a good argument though about whether or not it's physically possible. We may have reached a logistic cap on what we can do with lithium type batteries. So that's one thing. So one thing that Vijay Kumar has proposed, which I don't necessarily agree with, but it's worth having a discussion about, is integrating nuclear reactors into these aircraft, and then we can put these aircraft permanently in the air for forever, right? So if you have an aircraft, as an example, if you have an aircraft carrier with a nuclear reactor, that thing can sail around the world for 50 years without refueling, right? Imagine what we can do with an aircraft. Regulatory uncertainty. So I put Uber's picture here for a specific reason. So can you raise your hand if you've been on Uber in the last month? Yeah? Okay, good. So everyone knows. So you can have an argument about this, but in practice, Uber is basically running an unlicensed livery service. Now, I'm going to argue that I think it's great for society. I think Uber has done a lot. You guys have all taken it. You guys know how good it is, the advantages over regular taxi cabs. But fundamentally, they're violating a lot of state and local code, right? They are really doing that. So that leads to my primary point, and this is sort of, I think, the guiding principle for a decent amount of our peers in the industry. Sorry, not that. This one. So actually, I didn't realize this is a Grace Hopper quote, so it's actually very ironic that it is. I don't know why she would have said that. But the tough thing in this industry is that our technological progress is vastly outpacing the state of social acceptance of the technology, as well as the ability of businesses and politicians to react to it. Actually, for this particular industry, I'd switch that business line above the social line. I think businesses have broadly understood where this technology is going to be used and how it's going to be relevant. But again, politically, we have a lot of challenges facing how we're going to regulate this technology. All right, so before I go any further, I do want to comment some of the points made earlier about how we're going to monitor this the aircraft. So the reality is that at the lower heights of flight, it's extremely hard to monitor. Radar can't detect it. There's not enough people out there to catch you if you're doing it, and et cetera, et cetera. So it's really like driving an Uber car around. The reality is you can't get most of them, right? It's pretty much unenforceable. So I think if I had to make a policy recommendation to the United States right now, it's to set laws up on things that you can enforce and then just leave it open if you literally just cannot enforce it. It's not worth bothering if you can't enforce it at all. So there's been a number of things that have happened so far. So the first thing is that they created this Section 333 exemption, so you can apply for your aircraft and your company to have exemptions to fly. So that's been going on for a bit. And then second, this is one that came up very recently, very big for the market, is they released these new regulations on small UASs, the unmanned aerial systems. So to quickly go over some of those important regulations, so one of the key regulations on there is that you have to have a visual operator on the ground sighting the UAV, right? So I don't think that's completely unreasonable right now, but it's something that we may want to rethink in the future. So and then another thing is that the visual observer can only work with one UAV at any given time. You can't have more than one going at any given time. The downside to that is we won't be able to have any of those cooperative technologies in the near future because it wouldn't make sense to have 10 UAVs if you also have to have 10 men out there. So beyond that, it's been relatively flexible about who's flying and who's not flying. So there's a certain amount of autopilot that the new regulations are going to allow. But again, that's one that's unenforceable. How do they know if I'm flying it with a computer or flying it with a joystick? You can't tell that. And beyond that, the regulations are fairly good for our sector of the industry because for what we do, we fly in areas without a lot of population, basically over oil fields and over mining sites. There's not a lot of people. Everyone has like huge amounts of general like errors and omissions insurance, and it's fairly doable. But again, the regulations as they stand limit a lot of the goals that Amazon and DHL have had with package delivery, as well as operating in human environments with cooperative behavior. So that stuff is out for now. But again, if I had to bet on it, everyone's still going to do it anyways, and then eventually the law will change to react. Does anybody have any questions on the regulatory environment? Okay. Go ahead. Yep.
So I think I know the answer to this, but the observer has to be on the ground, right? You can't be up in a helicopter monitoring a UAV.
Oh, I don't remember that.
Pipeline.
I think it's on the ground. I always assumed it was on the ground. I'm not sure.
I figured you would know because
yeah.
I think for your application, right? If you still need visual on a site, there's a limited length of pipeline that you can actually see until you need another person.
That's right. So the way it works for us actually is we have somebody drive along in a pickup truck, and the dock station's in the back of the pickup truck, and they go along the whole pipeline, and then the UAV is flying over the pipeline actually. So that's still okay. Ideally speaking, we'd like to be in a scenario where we don't have to have anyone there at all. Like our system is automatic, self-pilot. We don't need anybody there. Go ahead.
Yeah, what would you say is driving that regulatory change? If anything, is it entrepreneurs lobbying the government?
Yeah, huge amounts of lobbying money being thrown at DC right now. So Google and Amazon's and everybody, there's a huge lobbying force to try to change those laws. And actually, interestingly, not a lot of repercussions on the other end. So in terms of the people against it, they don't have a lot of money. So ultimately, I think the people who want UAVs are going to win. But the interesting thing I think about this, the current state of affairs is that it's not really like political opposition. Like it's more just that like I don't think Congress has really gotten to it, and it's something they don't really want to think about right now because it's the kind of thing that like Congress would prefer to just let the FAA do because if they try to make a big discussion about it, a certain portion of their voting base is going to like get angry about it. So it's the kind of thing they just want to slip through, right? They just want like the way you might want to pass like things. So for example, like net neutrality is one of those things that like obviously the public is for, but like there's certain businesses that like are very against it. So like they're going to want to like sort of run it through back channels, which is what they tried to do. So I think this is something that's going to play out entirely in the regulatory sphere. I don't think we're going to see Congress engaging too much. Go ahead.
Have you looked much internationally? Most of the industries you named have a larger footprint, like oil and gas.
No, I think that's a great point. So we actually, as a company, haven't moved towards that route. So just because we're located right in the Marcellus Basin, so then we just have that market there. But to your question, I think the regulations vary extremely wildly. Like I think Australia is pretty much unregulated. Scorpions and stuff. It's basically Wild West out there. And then other countries, it varies like very, very dramatically. One challenge that we face is there's certain export restrictions on this technology. So like because it fundamentally is historically a military technology, even if it's not being used for military purposes. So import-export has been uniquely challenging. So we haven't actually addressed that question yet. So are there any other questions? Go ahead.
Are you guys, sorry, I probably missed this. Are you guys operating now? Like
yeah.
You're operating commercially?
Do you like our services? I'm going to do it anyway. Just think about it. Think about it.
So do you guys have a Section 3333 exception?
We're in the process right now. Yeah. So we'll get it eventually. All right, go ahead.
How do you avoid anyone hacking these and taking control of them?
That's a huge challenge in the industry. I don't have a great answer for you on that. I think the biggest thing that we're going to have to do is have sufficient autopilot, as you alluded to, like on board the aircraft, such that if that signal link between the ground controller and the aircraft gets lost, the aircraft will pilot itself and then land on the ground and do what it needs to do. Are you alluding to like signals, like stealing the signal, or like
stealing the signal, stealing the images, taking control of the aircraft? Or,
yeah.
I mean, what sophisticated hackers and teams might be able to do, or even if it's about national security.
Yeah, no, it's a tremendous challenge. I think actually the U.S. has lost UAVs to Iranians because like they've hacked that signal and been able to take it down. I don't have a great answer for you that right now. The big thing is, well, it's not really a problem specific to our industry. It's a broad problem with cyber intelligence and cyber warfare as a whole. But again, so I think the best solution for safety in the short term is we got to have automatic piloting to take it down in a certain flight path back to the home location. So our product in particular, if it cuts out on signal, it flies back to the home location, which is the dock station that you saw. But again, yeah, it's a big challenge facing the industry. Absolutely. Good. All right, so where is this market moving? So I want to give you guys a couple semi-large predictions. I stand by these predictions. I think there's very valid reasons you might disagree with them. But these are all predictions that I've actually personally put money down on and time down on, so I believe in these things. Good. All right, so where is this market moving? First, the basic technology is going to become commoditized with trends towards incremental innovation. So the prices on UAVs are going to continue falling and falling. The basic components of the product will be cheaper and cheaper. Right? So that's not where the competition is going to be. So we're going to have to find new ways to generate value in that industry. Professional services are going to develop around the UAV industry, and this is something that's going to be relevant to many of you in the room. So one thing that's sort of obvious that we need to work on more in the UAV industry is providing insurance services. So it turns out the liability issues around UAV aircraft are actually very different than you might have for like manned aircraft, right? Because you don't have to insure the pilot. But you also have the issue of like aircraft coming down, the hacking issues that you talked about, all those sort of things, and that needs to be priced into the insurance. So many of the big insurance players are coming in and trying to compete on this market. Beyond that, there's also going to be a number of like other professional service providers. So one of those will be mergers and acquisitions. So I'm going to bet that the market is primed for major acquisitions in the near future. In particular, we're going to see two kinds. First, the big general UAV producers, so DJI Innovations and 3D Robotics, the ones that produce the basic platform. We're going to see a lot of horizontal mergers between those two. The reason because of that is there's huge returns to scale. It turns out that they do exactly the same thing. It's the same aircraft, it's the same, like very similar motors, very similar controllers, and they have the same capabilities. It makes sense for them competitively to merge. Second, we're going to see a lot of mergers by non-UAV firms. And we've actually seen a number of these already for companies like Facebook and Google. They've acquired UAV companies, even though it's not really their core competency. But they sort of see applications for using that technology in other like things synergistic to their business. So Facebook wants to fly aircraft over unmanned aircraft over Africa to deploy free internet and stuff to areas. Google wants to, I think, part of it is to supplement their Google Maps stuff and do other data collection type stuff. So these companies are going to do that. I'm going to argue we're going to see that even more across the board. So in addition, we'll see it in delivery businesses. We're going to see it in oil and gas companies because they're going to want that capability internally, and they'll enter through that route. Generally speaking, it's going to be easier for them to enter through that route than to develop that technology internally. Personally, we know a number of big companies that try to do this themselves and just can't do it. It's a relatively specific thing that's sort of not related to their current capabilities. The hobbyist movement is going to exist alongside large-scale commercial operations. It's not clear how large, but I wouldn't put a lot of money on it. And then technology developed for UAVs are going to have other applications. So this is one exciting thing that we're going to see happen. So first, this is like a camera gimbal made by, I believe, DJI Innovations. Now, they actually are not a gimbal, like they don't make camera technology at all. But what it turns out is for their aircraft, they wanted to have a gimbal to stabilize the images coming off their aircraft, right? And they developed the gimbal, and it turns out you just make it bigger, like it's something that humans can use, right? So we're going to see a lot of spin-off technologies coming from the work being done in this space. Another one that we alluded to earlier is sensor fusion. So again, there's going to be additional technology developed for pinpoint accuracy of aircraft that we're going to be able to apply for other kinds of technology. So you can imagine your cell phone GPS and everything getting more and more accurate. This is part of a broader trend. The economy is going to shift towards automation and robotics. So part of this is technological change. Part of that is societal change. So key to that is that cultural comfort is going to form around automated behavior. So this is obviously the Google's self-driving car. I think as we see more of these things on the street, as we put more UAVs in the air and we demonstrate that this technology can operate safely, people are going to be more comfortable with having this around. And that's going to be key to increasing adoption. Finally, this actually isn't a prediction, but it's something that I do want to point out, something to reflect on as you guys develop your careers in the future, is how is this technology, not just ours, but you can include other automated technologies like Google's self-driving car, how is that broadly going to affect the labor market? And I'll give you a couple examples. So as a company Identified, if we do our job properly, that's going to destroy the value of a couple thousand jobs east of the Mississippi. Right? There's a large amount of people who do monitoring on the ground and fly aircraft that actually won't be needed anymore. Imagine Google's self-driving car. Oh, that's my phone. Sorry. Seinfeld. So, in terms of the Google self-driving car, that's the kind of technology that could broadly replace the transportation industry as we see it in the United States. You won't need truck drivers anymore, right? And there's a larger amount of jobs that could be and can be and will be automated, right? So how is that going to affect things? And something you should think about. All right, how can you guys get involved? So hopefully I did a good job selling the potential revenues and profits in this industry and the entertainment value as well. And how can you guys get involved? So I would recommend the following. So you guys should start following that news for regulatory changes, especially if you guys like trading stocks. I think like there's going to be a lot of action in the stock market whenever these regulatory things change. There's a lot of ways to engage in the industry around professional services. So we're talking about insurance, we're talking about M&A advisory, and other professional services that are going to go into this industry. You can buy a toy version and play with it. I do encourage that. That's a lot of fun, except I can't do it myself. And then build your own and play with it. That's even better, right? It's actually, the interesting thing is that the barriers to entry in this industry are not that high. You can buy all the components. It's 4 motors, a computer controller, and a bunch of plastic or metal, right? You can put one in the air. And also, Identified Technologies is growing. So I do want to make a sales pitch for our company. So this is our company picture from last year. So I'm going to tell you, I'll make it honest with you guys and tell you the real reason we need you guys. So one of the battles that we have is we always have a management, like sales versus engineering, like paintball battle, right? And for some reason, the engineers are outrageously good. We keep getting destroyed, right? So we're looking for a chief operating officer, another chief financial officer, and other staff as we grow in the next year to help, obviously support the company, but primarily to help our side win at paintball. It's been tremendously humiliating. All right, guys, thank you for coming. I have some brochures here if you guys want to learn more about the company. Otherwise, I'm happy to answer any additional questions. I'll take your question right now, and then we'll do the rest, or 2 questions, and we'll go offline afterwards. Yeah, go ahead.
So I'm curious about, I don't know what the right metric is in terms of the cost of monitoring, whether it's cost per acre or some other way to measure it. But when you're trying to pitch this to companies, how do you talk about the cost of this solution, and where is it that they see like, well, the potential savings are so significant that it just makes sense?
The simple metric that we like to point out is for the existing cost of what they pay a regular company to fly an aircraft in the air, like we'll be able to do it multiple times for the same price in a month. So that's the way we present it. So we could do it like 10 times for the price of 1. Mm-hmm. And then generally these companies are going to want more data. And
do you see that price coming down essentially because of all the trends you talked about in terms of? The primary cost is for us as a company is actually in our dock station. It's not in the UAV itself. So like in that case, it's going to come down as far as we can like mass scale manufacture. But I think broadly it will not. The one thing that's tough in the industry is that if the regulatory things stay the same, we're going to need visual operators on the ground who have certain licenses and stuff. That's the real cost driver in the end, if that's what it comes down to. All right, so I had one question here, and then let's take his too as well, but let's close out after that. Go ahead.
I was going to ask, so you own your UAVs, there is no leasing system or anything like that?
Yeah, no, we own them, but we lease them out to our clients, basically. Okay. So we deposit the UAV in the dock station on the site, and then they have a password that they can enter to.
And do you maintain them yourself?
Yeah, so we send our own people out there to do repairs and refurbish and everything. We prefer not, well, 2 things. Like, we think we're better at doing that than our client. And second, our client, by nature of the way the contracting works in the industry, everything is subcontracted. The main company does nothing, right? The main company just pays everybody else to do everything. So we're just part of that system. Yeah, go ahead. Final question.
Could satellites do it cheaper?
They can do certain things cheaper. They can do large-scale data, like big things, but at lower accuracy than we can deliver. Lower resolution than we can deliver, and also much less frequently. And interestingly, it doesn't work when it's cloudy, which is a surprising challenge because it's cloudy like, at least like 20% of the time. Yeah. All right, good. Let's close out there, guys. Thank you for coming.